Hey Guildies, Fletch here. Today I'm going to be talking about software engineering and architecture. It's sort of a new series that I'm going to be doing where I focus on what a software engineer does, which may or may not be different than a software developer. The main thing being that a software engineer does things and can also be a software developer. So if you say you're a software engineer, you're probably also a software developer. And in this episode, I'm going to be focusing on integration testing and health checks of an API. So let's get started. All right, I'm starting from the very beginning here, and maybe I'll do this sometimes, and maybe I will instead, keep building upon this same exact project or set of projects. So let's start with the basics here. I'm going to start with, gotta pay attention here. Gotta pay really close attention. There we go. Look at that. We did it. All right, so let's work using Git here. And I'm going to say, let's open Visual Studio. I could also do a .NET new API type command, but let's go ahead and just do this here. Okay, file, new project. Let's say, yep, an API. We're going to call this guild test. Yeah, that's good enough. We're going to put it into what was that? That was here. There we go. Create a solution. Next. Yes. Yeah, sure. Good stuff. All right. All right, we've got an API. This is the typical weather forecast controller. We're going to hit go, the magical go button. And there we go. Weather forecast. Try it out. Execute. Let's do something like this size right here. And we've got some weather. Okay, it works. Let's hit stop. Now, whatever our API is going to end up being, and it's all going to be test stuff. I'm not going to be doing some sort of a crazy awesome, we're building a game or something like that. Maybe it will be a game, but it'll be something as simple as tic-tac-toe or something. But I'm here not to show you programming tic-tac-toe or programming anything specific for an API. I'm showing you these are the types of things that I'd be doing as a software engineer beyond the domain code. And one of the first things I'm going to do if I build an API, well, I mean, I have a super base thing here anyway. Ooh, I need something like a git ignore. Let's see here. Look at my old repos. Here, maybe. Bam. All right. Just stuck that in there. Okay, so I have this. There's a lot of things I want to tear out because this is just the hello world stuff, but API creation. There we go. Well, okay, so first thing I'm going to start with is a health check controller, or actually an up check controller. So this endpoint that I'm going to make is just so that our continuous integration software, as well as once we're deployed, any of our testing software that's constantly hitting our production can make sure that it's up, so that we can keep track of the health of our system. So I'm going to start with calling this health check controller. That's a bit of an ambitious name, but it's okay. We will eventually have a health check as well as an up check, which are two different things. I'm going to say Marco Polo. All right, we have a health check controller. There's some things I don't care about for this, and that would be maybe that. In here, this is just for development, so I can just simplify this by putting these here without needing to say if it's development. We're not going to be deploying this to production at the moment. Simplify. Okay, that's pretty simple. This is just one of the objects used for that test controller they created for us. Ooh, let's fix this. And let's hit run again. All right, so we've started out. We have a Marco Polo. All right, here we go. So let's commit that. Not commit all. All right, guild test.controllers. Okay, so we have a health check controller. There you go. We have, well, at least the up check. We have the up check portion of the health check controller. Now, let's go ahead and create a domain that we will probably use later, but I'm going to go ahead and make some fake domain code real quick. Let's just restart the whole thing. Okay, bam, add new project. This is just going to be a class library. It's going to be called, you know, this is something that you can do if you make a mistake like I did. Guild test.api, and that doesn't even have a namespace. Save all. I need to come back in here. I need to close this real quick. That is so annoying when that happens. Okay. I have nothing else open that should be using this, but that's happening anyway. It's all right. I'm going to leave it ugly and I'll probably fix it in post. So let's go back here, to open it back up. I will fix it in post. Okay, so for now, I'm going to say add new project, class library, guild test, domain is what I'm going to say to start. So now the folder will be called guild test domain for that. And I'll have to go back and fix this later on because I really just want this called guild test. The domain is the king of the system, and so should be at the top. And so the namespace should be the simplified namespace. Okay, so we're going to call this domain service. Of course, we'd want a much better name than that if we actually had a plan here. I'm going to say public static string do something return I did something. Okay, this is just for later. All right, we've got that. And now the thing is, this API is going to be built and deployed somewhere. And there's going to be other things. Could be a front end, could be another API, could be within the same company, or could be a third-party companies hitting your API. Either way, you're going to need an SDK. Now, I'm currently interested in creating a C# SDK in case other C# code wants to hit my API. But you could also, of course, create a JavaScript SDK, or you could auto-generate an SDK with Swagger. There's a lot of different ways that you can create SDKs. I'm going to fix this. So I'm going to make an SDK now. I created my domain code. I'm going to create an SDK. So add new project, class library, guild test.sdk. Okay, this is build test SDK, and it is going to be have a constructor that requires an HTTP client, and it will have a method, public string upcheck. Probably going to want to make this a task. And we're going to say return client dot get async, of course, await. Get async Marco dot content dot read as string async, which we need to await that also. It's a double await. Sometimes you have an await and another await. We could split it up to two. I don't always think this is necessary, but I'll go ahead and do that. Our result equals this, and then await result.content.read a string. All right. This is called this. All right, we've got an SDK. And the SDK is not referencing the API. In your continuous integration process and continuous delivery process, it's going to package this as its own thing, send it to something like a NuGet repository, and then anyone will be able to pull that down and hit your API. The reason why SDKs are so good is because you can take in parameters, you can do everything programmatically. You can take in parameters, and then they don't have to know your API endpoint routes or how you want to format those routes onto those parameters onto the routes, or how you want to format the body. They don't need to do all that stuff manually. You just say, give me the client and HTTP client, and I will do all the stuff that you need to do to hit my API endpoint while all you have to do is follow my contract and give me parameters. You notice I'm not doing interfaces. I'm not doing anything fancy here. I'm just trying to get to what is an health check and upcheck, and what is a health check, what is an integration test. So I've got an SDK, I've got an API, I've got some domain code. At some point, this API is going to be referencing the domain code. Not that we're using it this second, but it will. So I might as well stick that on there. Add domain and SDK. Commit all. All right. Now, if we just run it again, we really just have the ability to see the upcheck. But we have a domain here. Should I make another API? Not yet. Let's go ahead and we'll make a console where we can run the console, and the console will test this SDK. And we'll go ahead and just stick this in the same thing. So add new project, console app, testbed. I don't like .console because then you get weird collisions with console.writeLine and stuff like that. Okay. All right, there we go. Look at that. It works. All right, so this console is, again, not going to reference the API. This is going to be a separately running executable that's going to be using the SDK to then hit the API. Let me just cheat here for a second. I could also go to the properties file, but I'm just going to go ahead and copy that. Okay, so I need to say var client equals new HTTP client, base address equals there we go. And then var SDK equals, did I reference that? I don't think so. Reference the SDK. Okay. New guild test SDK. with the client in it. And then I can say var results equals SDK dot upcheck. We need to await that. It is asynchronous. And if we run this right now, we should get an exception because it won't be able to find. Oh, we run it. Okay, the starter project's the API, so that works perfectly fine. If we make sure that's stopped and we run this console application, should throw an exception. The reason why it takes a long time and doesn't just throw instantly is because it actually does connect to localhost, but then no connection, the target machine actively refused it. So if you see that and you're like, why did it take so long? It's because it did connect and it was looking and waiting for permission to get to that port number. And then it's finally like, okay, the machine refused it. So it's not, it doesn't exist. It's just the machine actively refused it. All right, so let's run the API. I'm going to run it Control F5. And that will run it so it's not in debugging mode. And then I'm going to say, set that as start project so that I can just hit play button. And there it goes. Well, it worked. We got the result. We got Polo back. All right, so the SDK works. The SDK hits the API. If the API is up, it'll come back. I don't like that it throws an exception, though. So let me do something even better. Controlling your code with exceptions is unacceptable. And you should watch my videos about the maybe monad or learn anything about the option monad or anything about monads. So I'm going to actually use that here. I'm going to say a maybe of string. Oh, it automatically put it in. Okay, so I'm going to put a maybe of string, and I'm going to say, that was weird. Return maybe.try. This is some functionality in our library. We're going to have to do a wait. Maybe.try async. And we're going to try this. Okay, so we're going to say in a try async, what this does is it essentially puts a try catch around your code. And if there's an exception, then it wraps it inside of a maybe.none. It does a lot of the boilerplate stuff that you would have to do anyway in order to return. Always make sure you're returning a maybe and never throw any exception. So yeah, this is not typically part of a maybe library. This is part of the Gin Studios maybe library to get rid of a lot of typical boilerplate code. So inside of this essential try catch here, so we're still doing the same thing, get the result and return it as a string. And I will go back here and say, interesting. This has a reference to the monad. This has a reference to that SDK. Maybe I need to rebuild. Oh yeah, okay. All right, so now this is a maybe of string. So I'm going to say with this, I'm going to handle if there's some, and I'm going to handle if there's none. I don't need this breakpoint here. All right, so if something does come back and there is a match, I'm going to say console.writeLine sum, and that should be a string. And really, I can just put console.writeLine directly into here because it's a string and console.writeLine takes a string. And if there's none, I don't think I care about if there's none. I'm going to say I don't care. All right, yeah. So, bam. Guess I should have probably. I'm gonna flip around how I'm doing this. I'm gonna say set a start project, save, close that. So now if I hit Control F5, it starts the API, but then I can click on this and say debug, start new instance. There you go. We got Polo actually written to the console now. Okay, so we've got a little bit better code. Better code with monads. Okay, so when we have a CI/CD process and this is running, they can hit our up check. Now I want to do a little bit more. I'm going to add another controller. It actually does some domain stuff. Domain stuff controller. And we're going to say I'm actually going to go ahead and make I'm going to do this in a quick way. Yeah, that works now. Okay. Okay, so I need to put this. Yeah, that's good. That's good enough. Let's move this to its own file. Okay, that was weird. Now I'd rather put this inside of like a core library, but they would all build the same anyway. I'm not sharing it, so I'm fine just leaving it here for now, just since we're doing test code essentially. All right, so this would be, let's make sure we put this here. This do something. There we go. All right, so we have an API endpoint. It does something. Let's run it just for fun. Domain stuff. Try it out. Execute. Ooh, fun. Oh, okay. Yeah, dependency injection. This is also a big reason why I like manual dependency injection, because if I did happen to have some dependency injection, it was picking up types, and I don't know which type it's picking up, or if there's throws an exception, then it doesn't tell you exactly what the problem is, like with which argument of the constructor it was. So I like manual dependency injection. I can spell builder. We did it. All right, now whenever one of those controllers or anything else asks for an iDomain service, then it will be given a domain service. And here we go, get domain stuff, try it out, execute. I did something, yay. Okay, and let's stop that. Let's go ahead and stick that inside of the SDK. Do something. Wait, what did I just do? Sorry, I'm going crazy. I'm actually thinking about a lot of other stuff. Should I call this do something? I'm gonna call this do something. This is the time to think about it since we're deciding what the contract is. Actually, the time to think about this is when you need domain stuff like this. You need to expose a new contract for what needs to be done. You should put a lot of thought into um, what needs to happen. You need to think about, okay, well, if I were to test this, what would the use cases be? You need to talk to whoever's going to be consuming this. Could be another API developer on a different team. Could be a company who you're building this for, who's going to be consuming consuming the SDK, which is going to be hitting your API or something, or talking to a web developer. If the web developers are they need a new endpoint to do something, talking to them, deciding what the contracts are going to be between you. So there's that. Okay, so we have do something. We have the SDK calling do something is also a string, and yeah, I think everything is good there. All right, we have do something. Now we can do, let's say, a data service. Yeah, it works. Okay. I don't want to be lazy on this. I'm going to go ahead and say, bam, add new project, class library, guild test dot, it's called dot data or data access layer or something like that. So next, create. Let's go ahead and start public interface iData service, which will string get something. Yeah, that's good enough. And then I'm not doing Dapper or Entity Framework or ADO. That's a whole world of things to go over. I'm going to say I got something from the database, and I'm going to say object data connection. I'm not even going to be using this, but the point is you're going to be injecting either a connection string or a SQL connection or an Oracle connection or something here, an ADO connection. It's called an ADO connection. I forget right now, but something in here that allows you to connect to the database. And then down inside your methods, you're going to be using that data connection. Actually, just for fun, public bool connect to DB. Okay. Extract interface. Extract base class. Thought we could extract interface. Am I forgetting something? Oh, well, it doesn't matter. That's weird. Okay. 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 Not good. Just for fun, I'm going to go all the way. Maybe. No. Maybe a string. Return maybe dot. No. I'll get to that. Couldn't connect to the database. Nope, not project reference. All right. So it's a little bit fake, but we are sort of doing some stuff here. And I'm doing all this that I can show you integration testing, the patterns for it anyway. I swear I clicked that before. Nailed it. Okay. This needs a reference. Now, in reality, even more important than before, this should only be referencing a data.core, not directly to the data object, because the domain shouldn't even be able to access the implementation details for the data object. And you want to sort of keep those things separate. But I'm not doing that at the moment. Okay. Now, this is what I'm talking about. You don't want runtime errors happening just because you happen to have, if I didn't have this, if I just had this, for example, it's automatic dependency injection. I wouldn't know that. And maybe if I'm changing these things and it doesn't affect the exact thing I'm working on, and then I push out, you're going to get runtime exceptions. Is that what we want? It's not what we want. So we make sure that we do this, manual dependency injection. Get required, that was weird, service, data service. Okay, and then add transient, data service. Even if you did this, I swear. Even if you did this, it's not showing you an exception for, bad constructor or constructor change. So I can happily also do this. New data service, and that should be an exception. Get required service, type data connection, and then I did not want that. Data connection. I'll just keep it so it's uniform. All right, so I'm not a huge fan of primary constructors for classes. For records, I am. So I don't know why it's doing that. Okay. Do something. I'm going to return instead. Get something. This is a monad. All right. Just like when you do, you decide to make something async in somewhere deep in your code, especially data connections and stuff like that. And you have to like propagate it all through your code all the way up to the entry point, and that ends up spreading like a virus through your code. And now you've got async task of thing that you want to return, and it's like So if you're new to development and you don't use async, then that sort of is frustrating or confusing and it seems messy. But eventually it just should become second nature. And the same thing happens with the maybe monad or option or whatever monads you want to use. So it seems weird, but it is great. All right, maybe a string, which means we need to propagate this change up. And I actually have a library I'm not going to input right now. That does a lot of checking at, this is the entry point, so it can take the monad and split it apart and do checking for whether or not it has a value and all kinds of other stuff. But I'm not going to do all that right now. So return value equals this, and then let's do this dot match. I just like plus equals. These are strings. I guess plus equals could sort of work, but I just want to assign it. And then return value. You should never get the value out of a monad necessarily. 99.9% of the time throughout the code, you should be using binds and matches, map filter reduce type stuff essentially, and getting and working with the values when you can bind to them. So don't copy this. Like I said, I have libraries that make this prettier. So anyway, we have that. Let's go ahead and run it and see how we're doing. Marco. Polo. Got something from the database. Look at us go. It's crazy. Okay. As you can see here, a lot of what I'm doing is scaffolding, setting up tests, which I haven't really done the test part yet, but a lot of engineering. Now, you can also be the developer if you're the software engineer. You know, take off your engineer hat, put on your developer hat, and a lot of what you'll be doing is what's called imperative shell functional core. So you may be using this area right here in your domain service, which shouldn't literally be called domain service. It should have a name that makes sense. But you'll be using this interfaced method to compose functionality. Part of that composition may be getting stuff from a database. Or you may be, especially if you're being monadic, you'll get stuff from a database, you'll bind to some kind of functional method, and then you'll return the results of that stuff. And the bind will propagate either none or it'll propagate some. It'll get through the whole process. And I explain a lot of that in my maybe video. I have two maybe videos actually. So this is where you'd be doing your composition of your method. There shouldn't be conditional transformations in here, because if you're doing functional code, that should be in the functional core. This is essentially your imperative shell. This interfaced method that has a contract of what you need, of what you want, is where you would put your composition for your method, and it should be composed of some calls to external sources, databases, data access layer, operating system, third-party SDKs, and also composing in functional code. And all of the stuff I'm talking about, which is the majority of programming in a system. Like once this gets built out, you'll have multiple domain services, all kinds of functional logic, business rules, business logic, all that stuff in here. That's the software development. That's the real programming. And a lot of times, I'm not the best person for that job. Most of the time, I'm not the best person for that job. When that job requires a very serious understanding of computer science and algorithms that are going to be so performant that you must have a very high degree of understanding in mathematical principles, calculus, and all that sort of stuff. I can do it. I can do most of that stuff. It's not going to be as good as a lot of the people that I see. The people who code golf, the people who do the AOC challenge, Advent of Code challenge, and they get like the top ranks and stuff like that. That's programming. That's the hardcore, epic, amazing programming that you put into here, and you do software development, and it blows my mind how fast people can do AOC challenges and get those double stars up there. Now, again, I can do it. I did this year's AOC challenge and prior year's AOC challenges. I don't do it nearly as fast as they do. But that's not what we're doing right here. What we're doing in all of this stuff is software engineering. And this is really just scratching the surface of the software engineering. There's a whole lot more to it. But that's where there's a disconnect between what is software engineering and what is software development. And like I said, a software engineer can also be a software developer. But I really specialize in software engineering, and when I take off that hat, put on my software development hat, I'm I'm a great software developer, but I know so many people who can write algorithms that will just they're just so amazing. So there's a big difference there. One's not better than the other, but in order to be a software engineer, you have to be a software developer. So there's that. There's a little bit of a progression there. Okay, so here we go. This is where all that stuff would be, but that's not what I'm testing. What I am going to try to go through here is I tested it and made sure it worked, and now let's test the SDK. Okay, so Control F5 to run the API. And then let's run this. Let's come back over here. Oh. Since I'm in Visual Studio and Visual Studio only has one debugger, even though you can debug, run multiple different things separately, the debugger is attached to the API, and that's fine. And I can run another debugger when I do this. It essentially runs another debugger, but since it's a manually run debugger, it is actually I'm sort of saying some of this wrong because I'm not even debugging this. I hit Control F5. So, but this is using, I guess, the main console window. I'm not exactly sure why this happens. So whenever I run this, debug, start new instance, it doesn't open the typical console that is going to pause for you and let you read the information. It auto closes. And it's all because I'm running all this in the same solution under the same Visual Studio. So Polo got something from database. Did the upcheck, and I got something from database. So close that. I say I won't leave it open. There we go. All right, so everything seems to be working. Let's commit it. Did some domain and data scaffolding. All right. So when I want to do a health check, an up check, I will have my CI/CD process. First of all, somewhere along the process, it's going to be deploying this to something like a staging environment. Staging environment is not the end of the line and should not require any manual human interaction. You deploy it there so that you can run it and then make sure that at a super high level, actually at a fully functional level as much as possible, that you can hit these up checks, that you can do your all of your different types of integration testing. And I say that because that's everything that's not unit testing. Unit testing runs when the code is sent to, pushed to trunk, and then it's pulled into the CI process, and then it builds it, it runs the unit tests, and then it deploys it to something like a staging environment. I may or may not be skipping steps. I'm just trying to focus on what I'm doing here. It deploys it to the staging environment, and then it hits the whatever integration tests, and those can be API contract tests, they can be acceptance tests, they can be whatever tests that you think should be hit, run through something like Postman or through ADO. Azure DevOps, man, just all the terms they all make sense. Or something that's hitting it externally will be running integration tests. And these are all different. I call them all integration tests because all of them, other than unit tests, are going to be integrating with other things. What I'm going to be focusing on here is what a pure or real integration test is. So one of those tests that they run is an up check. That's not an integration test, but it is it just makes sure that, okay, the API is there. Step one, now let's move on to acceptance tests and stuff like that. But an integration test would be this. Just keep it the same. Okay. And then maybe a basic query test like select table count or something like that. And then we'll say if result return this. Success. Actually, you probably don't want to do success and failure. In real life, you'd want to do return a different HTTP status code instead. So success, you return 200. Failure, return um, maybe a 500 status code of some sort. I'm not really focused on what number that should be right now, but essentially return a success, return a failure. So this is an integration test, and we can run this. You can have your CI/CD test this integration, try it out, execute, success. We can connect to the database. So this is what integration tests are. And next time I'm going to, should I do it next time or should I do it right now? I have time. I'm going to go ahead and do it right now. Maybe I can split this up into multiple videos later on, but this will only take a second. Stop. Bam. Integration test commit. Will this only take a second? Yeah, I think it's for another video, which is great because I need more content for other things later anyway. Tomorrow I'll probably be talking about agile principles again, and the next day I'll probably be talking about the next phase in integration testing because there's a really important next step which may end up taking 20-30 minutes to get into, so I don't want to do that at this moment. So thank you for coming. Thanks for watching. And I appreciate all of you. Like and subscribe and leave a comment. Leave a comment on anything. A question is always good. I love questions. So